Hey everybody, this is Larry. Hit the like button, hit the subscribe button. Let me know how you're doing this problem. I'm going to solve it live right about now. Okay, so 420. Okay, 420. Strong password checker. A password is considered strong if the below conditions are met. It has 6 characters and at most 20 characters. It must contain at least one lowercase character, at least one uppercase character, and at least one digit. It must not contain 3 repeating characters in a row. AA is weak, okay, but AA dot 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 AA is strong, assuming other conditions are met. When a function strong password checkers that takes a string S as input and return the minimum not change required. Wow, that is required to make a strong password. This S is already strong, return 0. Insertion, deletion, or replace of any one character is all considered to be one change. Okay. Wow. So this is potentially a tricky. I mean, it is a tricky problem no matter what. So it's not potentially, but I think the first thing that comes into my mind is wondering what n is, because that it just bounds out problem a little bit in terms of analysis, and I would prefer it. My instinct is that this is going to be a dynamic programming problem. Minimum change required. But it's kind of hard. So you can. There are a couple of ways to think about it. You do a brute force recursion type thing, and then try to cache it. It's going to still give you issues because the potential number of strings are still a lot. So how would I think about this? So how I think about this state is, okay, so I don't know if I'm going to be able to explain this well, because I don't even know if that's the right answer, but I think that's the first thing I'm going to try to implement, assuming I'm on a contest mode or something like that. So my dimensions or my states for this dynamic program is that I list out all the things that can change. So the first thing I have is index. So this is the index of the string S that we are currently processing. So I have maybe at least, so like a Boolean thing of like lowercase constraint satisfied. Is that type? I can't spell, but okay. Lowercase constraint. So Boolean to show whether we implement, we have a lowercase letter, uppercase constraint, Boolean to show whether we have an uppercase letter, and then one digit. It's also just digit constraint. Okay, Boolean to show whether we have a digit, right? And then 3 repeating characters in a row. So that's going to be the tricky one a little bit, because there are a couple of ways to do it. So the easy way, maybe, is just to show the last 2 characters. So I think the tricky thing is trying to prove the number of states, which is going to be a little bit trickier because in terms of, this is one problem that I would try to do top down with memorization or dynamic programming, because there are a lot of unreachable states in how I represent the problem. So how to implement this 3 repeating the characters in a row is I'm just going to have two characters. So last character used, and then second last character used. Okay, and then now you may want to analyze the number of states, right? So index is just, let's say n is equal to the length of the string, then index will just have n possibilities. These 3 things are Boolean, so they're 2 possibilities each, so 3 of them combined is 8 possibilities. This is the trickier one to analyze, because I think naively, if you look at a character, it could be, let's see, 26 times 20, or sorry, 26 plus 26 plus 10. So maybe it could be 52 characters. I don't know that. I don't know that if it could have even like other ASCII characters, right? So let's just say ASCII characters then, because it's not super specified. There's no constraint showing that. I wish there was. But in that case, then it's just 256 times 256. So if you put it in a calculator, as I am going to do now, because so you have 2 to the, oh, so that's n times 2 times 2 times 2 for the lower, upper, and digit constraint times 256 times 256, right? So that's kind of our situation. And that's equal to, well, n times 500k. So that's a little bit high, right? So if this is a problem where if you try to do bottoms up, you're going to run into trouble. So I think what I would do is but you can actually constrain it a little bit better, because in each of these types of categories, because I'm a little hand wavy at this point because it's a little tricky to show, but I think in terms of the characters you can use for so this will only come up if you're not changing characters. If you're changing characters, then you can change it to some, like you could really change it to anything. And by the pigeonhole principle, there are only really, like 2 or 3 characters per each character class that you can use, being generous about it. And what I mean by that is that let's say these are all, let's say you really need to change it to a lowercase constraint, right? Well, let's say if this is A and this is A, then you could just change it to a lowercase b, and that already ends the streak. So there's no big deal. If you have to change it to uppercase, same thing. So in a weird way, a pigeonhole principle kind of way, you only need 2 characters for each type of these constraints if you want to use that change. So in that case, this constraint should really only be, I don't know, let's say it's still a little bit generous, but I think you could constrain it to 8. In that case, I think I'm lock it up. I'm plugging into a calculator now. This is actually 2 to the third. So actually this is 2 to the 9, and 2 to the 9 is like 512. I should have just did the math that way. But now we reduced the state to 512 times n, which may still be too big depending on what n is, but we don't know what n is. So, but we know that it has at most 20 characters. So maybe we can think of, maybe we can think about, maybe additional constraining that way. But I think we have enough to be able to, to kind of implement our recursive function of dynamic programming. Okay, so let's just say dev, let's just go and check. It doesn't really matter. So you have index, you have lowercase, or let's call it is lowercase, is uppercase, oops, is digit, is it is digit or has digit? Let's go has, because it signifies that we've already satisfied these constraints. And then, and then last character, and then last character, or last second character. This is a really long function, but maybe I need to, I guess now I could change this a little bit. Okay. Huh. This is the first time I need it. I mean, I know that this, okay, actually, fine. I'm just being annoying. Let's try to keep some form of 80 characters, and then we'll just do it this way. Okay. So now what's your base case, right? I think we need one more, actually. We need character. I think that will save us some space, actually. Because here we don't constrain on the characters used, but if we keep a track of characters, then we could limit the possibilities that n can be, kind of. maybe. I don't know if I make sure or not. But let's say times 20 because after 20 you will just fail anyway, right? So okay. Oops. Spacing is hard. Number of characters. Number of current characters in the current string. Right? Oh, I guess get min is a better name for this. Okay, so now let me just move this up because it pairs a little bit better with the index, I think. And then now let's just use characters used. Or characters used, characters has characters, number of characters. Num character, okay. Okay, let's just start. I mean, naming things are hard. Okay, so, well, let's go over some base cases then, right? If number of characters, characters, let's be good at grammar. If it's bigger than 20, we already return, let's return, I would say return false technically, but you want this function to call min. So get min will be, let's just choose some infinite number. So let's just say infinity and beyond is equal to, was it full infinity? Infinity. And also as a kind of a worst case scenario and analysis, no matter what the string is, it will take at most the length of the string, you remove every character plus just create 26 random characters that satisfy these. And so in theory, the most number of moves that you need for changing whatever is the n plus 6 or something like that, right? So that's just like a back of the envelope thing, and that will probably not come into play because obviously that was a pessimistic one because you can, as mentioned, when you change one character, you could get two characters at the same time, right? So yeah. So okay. So now, oh yeah, let's because this is memorization. I'm going to use this thing called LRU Cache. So so this is a bit Python specific, but what this function does is just lets me cache. Given these inputs, if I see the same inputs again, reach it from the cache instead of doing this calculation again. And it's just a shorthand. We could have written this out, and in your language, you might have to. But in Python, I get to do this for free. And the none refers to the fact that in an LRU cache, it actually pops off your most recent or least recently used. But if you set it to none, that means we want to keep everything. Yeah. So that's kind of how. Oops. Cool. So this is an easy base case. Let's go over other base case. So let's say if index is equal to n, that means we process the entire string. Now we get to check all the conditions, right? If number of characters is less than 6, or not has lowercase, we haven't had a lowercase, or not, oh, oops, I didn't do comma because I was too busy. Has uppercase, or not has digit, or I guess that's it because we already because at least for me, our precondition is that these two don't already have. Yeah, these two doesn't. I mean, whether they match or not doesn't matter because we're not adding any more characters because we're already at the end, right? Well, is that true? Well, I guess we can. So what I was thinking was that whether like technically you could just add some characters to satisfy it if it's less than 6, but we can do that in code instead of in the index. What I mean is that we could treat that as part of the transition instead of part of the base case. So that's okay. Anyway, in this case, return infinity and beyond. Yeah, I'm going to keep making that joke. Sorry. and then otherwise return 0, meaning that your job is done. You don't need to modify anything, so that your base case is 0. Cool. Am I good here on the base case? Let me think for a second. Maybe I'm okay for now. Maybe I need to come back, but for now, I think I'm okay. So let's think about the transition. So let's say we have a best result. Let's start off at infinity. We return best at the end. What's our calling function? I guess we'll actually do it later. I'm doing a little bit out of order, maybe. But okay, do I have everything I need? Sorry, I'm just collecting my thought for a second. All right. So now let's say we're processing S sub index, right? Okay, let's just say we want to keep this character, keep S sub index. What does that mean? Well, that means best is equal to min of best of get min. So index goes up by 1 if we keep this. Number of characters goes up by 1. Has lowercase is equal to has lowercase or I'm doing like need to clean this up a little bit, otherwise it looks like I'm doing code golf. Is this or S sub index is lower, I think. I forget if it's lower or it's lowercase. It's lower, okay, and it's a function. So basically this is saying, I get a lot of random. This is saying that if has lowercase, like we already had lowercase, or the current character is a lowercase character, then we set this to true for the coin. So that's what it's saying. Let's actually format that slightly. And similarly, has uppercase or S sub index is upper, and has digit or S sub index is digit. And then last character, so this new character will be the last character, second last character, or last second character, yeah. Is just, now your last character becomes your second last character. Okay, so that's one of your base case of keeping S sub index. And then now let's say, what are our possible moves? Insertion, deletion, or replace. Okay, just want to make sure. So let's say we want to insert, we could insert anything we want, right? Okay, let's just say we want to insert a character. Okay, yeah, insert a character. What kind of character can we insert, right? Well, we can insert an uppercase letter, a lowercase letter, or a digit. So let's try that. And I think we can actually maybe even do a little bit greedy in looking at the last character. Just choose. Can we? So I was just thinking whether we can just choose one that is in the last character, and even though it seems obvious and it is a little bit greedy, I think for a second I have to think, well, is there a case where we want to choose last character and later it leads to a more optimal choice? I don't think so. So maybe that's okay. Yeah. Okay, so into the character, and then now let's branch out to insert a lowercase, and then I'm just going to copy and paste these notes. Uppercase, and insert a digit, right? I should have done deletion first. Deletion is so much easier to write, and you'll see later. But yeah, so now let's insert an uppercase. How come this? I don't know anymore. Okay, so what happens when we insert a character? Well, index is the same. The number of characters you you have a new character, so number of characters is 1. So has lowercase equals to true, so let's just set this to true. True. Has uppercase will not change because these are, and or has digit, both 9 of them should be changing because these are all mutually exclusive, right? So then now let's insert a random lowercase character. I think we don't even need to do. I was going to say, I guess we could put in something just for reference, but do we need to put in everything? That's my thought. But I think just for the sake of, and this may increase the search space a little bit, but I think maybe it's an optimization that's a little bit premature and adds complexity. So I'm just going to do something kind of naive, but let's just go. Okay, let's just go if. I'm going to do it in a ternary statement, so bear with me. If last character is equal to z, or z, if you will, then we just do, I don't know, x. It doesn't really matter. Like something not z, right? Else, we just do z. Right? It doesn't, yeah, I mean, it doesn't really matter. And then the last character is, or the second last character is now last character, similar to the before. Right? I think this is the transition. Okay. Cool. And I think now I want to take a quick pause just to make sure that like I don't have syntax issues or whatever. I'm just gonna just write something to call this function. So we want to get min of first we want the first index is going to be 0. So now to keep it scrolling up because I forget because we run so much. Number of characters, so we start at 0 number of character. Has lowercase is obviously forced because you have no characters, we have no uppercase or digit. Has digit, what is has? Oh no, I did has digit. Last character and second last character. We can just use empty space because we don't have a previous last character. Okay, let's just run this real quick. We obviously don't expect the right answer, but I just want to make sure that yeah, I just want to check compiler issues or something like that, so I don't have to fix them all later. Okay, so this is how you would insert a lowercase letter. And similarly, let's do the same for uppercase. And oops, I mentally copied and pasted. Sorry. Even though I was typing them out, why do these not match? Why do you don't match? Okay, fine. And similarly, we'll just use X multiplied. So something like that, right? Okay. And then now we have to insert a digit. And if you think this is tricky, you are right. Okay, this time I'll just copy and paste. I don't have to. I mean, I don't know. It's fine. Let's use 9 to keep it slightly consistent with what we're going to do. Okay. So that's inserting a digit and inserting things. Let's see if we actually get a number. Is it possible to get a number? Let's just run real quick just to make sure that it compiles to a degree. Oh, my input is empty string. Why is? Oh, I guess. Should we expect to have an answer for an empty string yet? I think so. Oh no, I guess not. No, because I feel like one of these should have kept on adding stuff to the point where that we should have at least an answer, even if it's not a great answer. Oh, I see why. Well, no, they should. I mean, it still should give me the wrong answer because I forgot something, which is that keeping the index, it costs nothing, so this is fine. But inserting an uppercase costs 1 change, right? So we forgot to do that, and by we I mean me. But gonna blame you. No, I'm just kidding. But now I forgot that part, so that's fine. What's the third one? Okay, but that's weird. That should still that should give me an answer, I think. So now I'm doing a little bit of debugging because I expected this to give me an answer, but it's returning 0. And I don't even, and I'm missing a case, by the way, where, well, I guess I don't have to, because for insertion, you definitely avoid the last character in the second, you avoid the repeating character in the row thing innately. Okay. Huh. I do expect this to give me an answer. This is why I'm pausing a little bit to kind of think, and maybe have to even debug, and that's fine. But let's print it out. Actually, I actually struggled a bit with LRU Cache debugging for that reason, but I actually wrote a helper that I'm trying to find if I have it. Okay, yeah. So I actually did write this at some point, debug print that allows me to just encode this. I forget if I should code before or after, but let's take a look. Does this have to be inside? We'll do this at some point because to help me debug during the contest instead of writing print statements all the time. Okay, so yeah, so it's not calling any of the recursive ones. Why is that? Oh, no, that's not it. Number of characters is greater than so index is what? Okay, that doesn't make sense, right? Oh, actually, that does make sense. I'm just being silly because, so we do have to take that. It is an edge case that I was hoping that I didn't need to take, but I do because for the 0 string case, then yeah, for the 0 string case, then you need to take care of this. We just have to fix this statement to conclude that, but I'm not. Let's try another case first. Whether I figure out what to think. Let's just say we have one character. What's the answer for me? Okay, so it gives me 5 as expected, so that's great. So that means that these insertions are working for me. It may not be perfect, it may not be ideal, but at least we can show that, I'm heading the right direction. But I'm still getting 0 for infinity, but that's okay, because I think now, with that, knowing that, we can just run a special case, because it's easier to handle it here than might have handled in general, I think. But yeah, in this case, just return 6, because you can insert 6 characters and it'll be okay. Because you could probably finagle into this logic such that it works, but there are more edge cases to handle. You have to count like the number of characters, you have to count the number of constraints that you've met and stuff like that. And it's a little bit messier to type, and I think this may be the only case. Okay, so now we have the insertions ready, we have to process, or we have to keep index, and then now we just have to do the other thing of deletion, right? Delete this digit. Best equals, so how do we delete, what does deleting this digit mean, right? So it means, well, index plus 1 because we processed this digit. Yeah. Number of characters remains the same because you didn't add a character to the string, you just deleted from the current string. Has lowercase hasn't changed, has uppercase don't change, has digit didn't change, and I guess the last character and the second last character doesn't change because those are the things you put on the string. But it does cost you one move. Okay. Just running it again, just for sanity's sake. And then now we can maybe start with a test case that's like, okay, AA, BB, AA. So that should give us 0. No, it shouldn't because we are missing some constraints. Okay. So that should give us 0. Let's check that real quick. Yep. But now let's say we have one more. Let's say we have one more thing and we want to remove, and that should give us the removal. Yep, still 0. Oh, no, that should definitely give us one more removal. But I think keeping this, we have to check. I forgot to check that. That's where we have to keep, because so basically what we want to do. Yeah, the reason why we have to check on keep, and that's why we checked it, by test codes. And this transition is obviously clearly a little bit, there are a lot of tricky things. But yeah, we have to check that if S index is not equal to last character, or S of index is not equal to the second last character. Basically, if it's okay, maybe this is we'll use Debugging. So if not, I mean, this is just Debugging, so it's the same thing, but it may be easier to say in English, which is that if the current character is equal to the last character and the second to last character, and we don't do that, then we get to keep the current index. Okay, now it should give us the one answer that we seek. Okay, looks good. Okay, but we still didn't do the change one yet. So yeah. Yeah, okay. So with that idea in mind, we do the same thing really, which is okay. Similar to inserting one. So now we change. I'm just trying to think whether I can shortcut this in a way, but maybe not. I mean, maybe you could do something to dry yourself with all these code, but I guess we have to do it. Yep, change this character. I mean, you could probably do it, but I think at this point maybe it's a little thingy. But into an change to an uppercase. And this is the same as this, really. Yeah, is that true? Yeah, I think this is right. And I think I missed the case, but I think you could probably dry yourself a little bit here, versus what I'm doing. But I think the way I'm doing now, it's a little bit more illustrative or more easy to understand versus, because I think I could convert this to a for loop and stuff like that. But I think this is, as I said, a little bit easier to understand. So I'm going to keep it like this, which is that now when you're changing a character, pretty much everything is the same as inserting one, except for that we move the index by +1, right? Oops. And same here for uppercase, and same here for changing a digit. Okay, cool. I think, and are those all my conditions? Well, those are all my transitions of one character. And we make sure that we don't have 3 characters in a row. And yeah, I think, okay. So I think this is all I have for this problem, maybe. Just thinking a little bit, just making sure. Let me double check the code. Maybe that's okay. Okay, let's submit it and then see what happens, I suppose. I think we should probably check a little bit more, but I think some of the trickiness with these problems is that just typing big cases is that I don't know how long these characters could be. So it's just tricky to know what the right answer is. I guess on a contest you won't know the right answer, but of course with you, if you're if they give you the expected answer, obviously you could just check that. And the running time is a little bit scary, so we might have to do an additional optimization. But let's submit it and kind of see how that fares, and maybe we run out of time or something. I don't know. Because it really depends what n is, and they don't tell you, right? So our code is definitely correct, but it may be slow. Okay, so it's really slow even, 7 seconds, but it is accepted. We definitely wrote a little bit things a little bit tricky. I think we can reduce the space a little bit with last character and second last character. We're using a string character, which is adding a lot to the memory. We use a lot of memory. Actually, I was going to say, I mean, I did say that we use a lot of memory, but apparently it's still less than 100% of the memory. So maybe that's why our performance is a little bit slower, but maybe we can get rid of a dimension or two, but I think I'm okay with the way that we're doing right now. Because we are correct. Let's see, there's no hint or anything, so okay, cool. Yeah, so this is dynamic programming problem. I kind of go over the complexity a little bit here. I think there are also input-specific optimizations that you can do. I think the tricky part about trying to optimizing for stuff like this is that they don't tell you the constraints. And also, I know that a lot of people really like to optimize for runtime and stuff like this, but for me, it doesn't really matter that much because there are a lot of stuff that just like very test case sensitive as well. What I mean by that is that the texture of the inputs might determine, your running time, but as long as it's good, it's good. And, it just depends on what kind of input they give you, right? So, yeah. And I think I think the running time constraints I think a good portion of them will be just constant optimizations. So I don't feel that bad about it because I think there are a number of things we can do to reduce the search space a little bit. Maybe we can, like this is a very pessimistic case, but we can probably do a little bit less even. Or like a number of characters is greater than 20, maybe we can just, delete all the other digits together so that you don't have to do it one by one and do this recursion thing all the time, right? Maybe. So there are a couple of things that we can think about, but overall, I'm not going to worry that much about it for now. I think the focus is on the problem-solving part, and I think on the problem-solving part, we did very well. This is dynamic programming, top-down memorization. As I mentioned, this is actually a little bit trickier to do bottoms-up, not necessarily because of the implementation complexity per se directly, but there are a lot of unreachable states depending on how you determine the last two characters and stuff like this, and that makes it a little tricky to find the ordering is easy to figure out, but it's about finding out the base case and then starting from those base case on a bottom up. You could maybe, from that, if you were able to, you should be able to remove one dimension, which is probably the index dimension, or maybe number of characters dimension actually, because then that will save you about 20 times in memory usage, and maybe in terms of allocating memory, since once you get to 230 megs, memory allocation will kind of come into play as well with respect to the running time. But anyway, those are the things that I would think about, but I would not necessarily need, for now, I'm really happy with that I solved this on the first try, and that we enumerate a lot of cases, even if the running time is a little bit slow. But yeah, cool. That's all I have for this problem, I think. Let me know what you think, and I'll see you doing another problem. Bye-bye.